My name is Adrienne Herron, and I'm the KTT lead for the Alberta AgriSystems Living Lab. I'm going to take a moment to acknowledge that the members of the Alberta AgriSystems Living Lab team are grateful to live, work, and play, and to be in relation with people from across many traditional territories covering all regions of Alberta and Canada. This acknowledgement is to reaffirm our commitment and our responsibility to improving our relationships, our own understanding of local Indigenous people, their cultures, and their knowledge. And with that, I'd like to introduce and thank Markus Weber for spending an hour of his evening with us tonight from Landview Drones. Markus grew up on a grain and cattle farm in Alberta, where he spent much of his time managing early precision agricultural technologies. He holds degrees in agriculture, law, and an MBA from the University of Alberta, and has extensive experience as a professional virologist and an agricultural consultant with Sericon. With an advanced pilot certificate with flight reviewer rating and a lifelong passion for precision agriculture, Markus has been instrumental in advancing farm drone technology for 11 crop years through Landview Drones. So thank you very much, Markus, for speaking with us tonight. I'm going to remind folks that if they have questions for Markus, they can put them in the Q&A or into the webinar chat, and we'll get to them at the end. And then I'll also take a quick second to introduce Dr. Edward Bork from the University of Alberta and Dr. John Church from Canada. So with that, there's your send-off, Markus. Thank you very much for coming tonight.
Thank you. So we'll get right into it. We got 58 minutes of drone time. Thanks for having us. And hopefully this is the type of presentation you're looking for, because I'm hoping to just rattle off a whole bunch of ideas. No peer-reviewed research here, though there is some, and Dr. John Church and Ed Bork will be able to correct me if I get anything wrong. But this is more just about how drones are used on the farm and give you some ideas about all the different scope, especially on a ranch. Get the presentation to start. So the types of drones that we usually classify, I mean, most people are familiar with the toy drones. We don't sell those at Landview, although many of the toy drones become farm drones just by being put in the hands of a farmer. And a lot of those we call them scouting drones. So drones that you fly manually, you take a look around, you see the forest for the trees by just getting airborne. Those types of drones are fairly cost effective, and that's what most farms that have invested in a drone are buying. It's just a consumer drone that they then repurpose for seeing the forest for the trees, seeing a full field, or finding cattle. What really makes a difference, though, and I'd like to start most of my presentations with this, is people will want recommendations on what drone they should buy. If it's an imaging drone, almost without fail, my recommendation is Zoom. And I've just got a couple of shots here that kind of demonstrate that. So you see that big black thing in the middle of the field. If your monitor's big, maybe you know what that is. But I'm going to take you there by just moving the scroll wheel on a drone. This is a Mavic 3, zooming in 2 times, 4 times, 7 times, 14 times, and 28 times. So without moving the drone, you can get this picture, that picture. And in the hands of a farmer, this is incredibly effective for just figuring out things quickly. I mean, you've probably all formed some opinions already on what you would want to see, but things like, is that a cow or is that a moose at the far end of the pasture when you're trying to empty pasture out? For crops, it's very similar. Zoom is important. This is about 10 meters above crop without any zoom at 2, 4, 7, 14, and 28 times. Again, without moving the drone, I can take that picture or that picture in a matter of a second, right? Just zooming in on a scroll wheel. And so I don't want to diminish the toy drones. If they have some zoom capability in the Mavic 3, the Mavic 4 Pro, all of those, even the Air 3S, they have some ability to zoom in. And if you don't have time to listen to the full presentations that I give, this is really the one thing that I like to recommend, is at least get some zoom on your camera, because in a farm scenario, it's essential for figuring out things quickly. This is thanks to John, actually. We did a precision ranching workshop together last year, and he let me use this video. Some of his students just really demonstrated what zoom on a video can do for you. So they're capturing a calving event, which is great. If this is your calf, you're checking to see, is it breathing? Is it not breathing? Is she looking after that calf? They did all of this, though, from John, I don't remember what height, but I think it was at legal height or slightly above. It was incredibly high up, and you'll get to see that here in a second. This is a Matrice 300 drone with a Zenmuse H20T sensor on it, 400 times zoom, right? Without disturbing those cattle, you're able to check them, and again, zoom is incredibly valuable, especially on a ranch. Beyond that zoom, though, especially in Alberta, I've seen some really positive effects of a government program, and it's an SCAP program, Smart Farm Technology Stream is what it's called, OFEP, the On-Farm Efficiency Program. It's only available in Alberta, not the Saskatchewan or Manitoba producers, but they can buy thermal or multispectral drones, so drones with, in quotes, agricultural sensors attached. And this is an example of one that bought one of those drones. Rob Farms here in Alberta. He had a heifer that was out, and he posted this on Twitter and lets me use it as a demo. I want you to look in this video to see where that heifer is. So they're looking for this heifer that's been out for a week. His son's in the side-by-side. They're trying to find her, can't find her, and there she is. So he posted this on Twitter, and I thought, well, Rob, have you also got the thermal video of that? So I asked him to post the thermal. So again, I want you to see when you see the heifer, and I'll just have the matching video. There she is, right? And I use this to point out how important thermal is for cattlemen. And with that 50% subsidy, a lot of cattlemen in Alberta are buying thermal drones because they become basically the same price as a consumer drone, and they get so much more use out of something like that. What I also use that video to point out, though, is how important the camera is generally when you're using drones. It's not just about, do you need a thermal camera? I mean, if you want to see a specific weed, there's certain wavelengths, multispectral bands in the near infrared often, that you would use to do that. If you want to see water or water stress, sometimes thermal is the right camera, but you can also do that by looking at the vegetation with red edge light. So there are certain types of cameras that will do certain things. And if you've got a very specific use, then look into what that camera is that would do that for you. The next category of drones is mapping drones. And in these scenarios, the drone isn't just in your control. You're not using a controller flying it manually, but rather you're sending it out on an automated flight. It flies a grid pattern of some sort, collects data, and then turns that into a data product, into a map. And those used to be that size. That was a Matrice 300, but now have been replaced by the little folding one. So the Mavic 3 was a consumer drone, the Mavic 3 Enterprise, Mavic 3 Thermal, Mavic 3 Multispectral. All of those are enterprise level drones that can fly in grid pattern and create extremely high resolution maps that can be used for different things. When you're using these enterprise level drones to map, you're essentially going from satellite being your best remote sensing data source, or perhaps manned aircraft having flown over your yard in 2012 or 2014 or whenever the last pass was over that yard, to then getting extremely high resolution data like this. If you're doing water course evaluation, you can see how these two sets of data that you see on the screen would be for very different purposes. That's not to say satellite isn't useful. It definitely has its uses because often it's free, especially with the Sentinel-2 data that's available to producers or anyone basically online. But free at that kind of resolution is different from a half-hour investment of your time to capture the one on the right with the 5 centimeter pixels or better. And so how that becomes useful is you've got these drones that then have multiple sensors. Like this particular one, the Mavic 3 Multispectral has been a really big seller because it's so affordable and has the multispectral sensor. So that complete package would run under $7,000. It's got those sensors on it that will show you crop health, crop stress, different vegetation classes if you're trying to classify vegetation along a waterway or that type of thing. And those drones collect data autonomously. So you just hit start, let them collect the data and create a map. That lets you do things like this. This is one of the first big mapping projects that I had back in 2015. The producer here had bought a seed drill with sectional control, seeded his entire farm, and then afterward noticed that the pipes had been hooked up wrong. So when the left end of the drill was supposed to be turning off, it was right end turning off for the entire farm. And there was no better way to quantify exactly how bad that impact was than to do a drone flight and map all of it and measure the exact acreage. They tried doing it initially with an airplane and taking a few pictures, but a drone at a $2,000 price point now could do this kind of thing. And you'll see a common theme here. Often the drones are being used when there is damage to crop already. So this is an example of a friend of mine that had hybrid seed canola production on this pivot. The neighbor to the east had sprayed, it drifted onto the east end of this field. And you can see the 2 acres that are outlined there. And what that 2 acre assessment did for him is let him make management decisions. In this case, the decision was don't even bring it up with the neighbors because shit happens, right? But there are instances, if that had been 14 acres, where now the insurance companies get involved, and you can help to settle a situation like this by having concrete data. When I was farming with my dad, he trusted me a lot to just experiment. Back then, we didn't have smartphones. I had a little flip phone, had to keep myself busy in the cab. So a lot of what I was doing was turning the nitrogen dial down and up as I was seeding, just for fun and for experimentation. I was doing 160-acre trials where I would do one run at my dad's blanket rate. The next run would be seed of your pants variable rate, essentially. I would move nitrogen from tops of hills to the side hills and from the bottoms as well. So tops and bottoms, all the nitrogen will go to the side hill. Where we actually need that nitrogen, the use efficiency is higher rather than the eroded knolls. I'm from central Alberta. So eroded knolls with very low topsoil didn't get the nitrogen, nor did the bottoms where there's more nitrogen than the plants even need, and they were lodging. So I love doing those trials. Had I had a drone at the time, I would have actually evaluated those results in June as opposed to after harvest. We were running yield monitors. Often the yield monitors weren't properly calibrated. It really wasn't great data. But if you do an NDVI map of a cereal crop or canola crop, just pre-flowering or just pre-heading out, at the end of the vegetative stage of growth, the correlation to your final yield is 0.85, 0.9. The R-squareds are amazing for correlation of yield to an NDVI map at the end of the vegetative stage. So you can essentially create a yield map in a season, and that does two things. One, it lets you correct it potentially, right? If this is something related to fertility and there's an opportunity to improve that fertility mid-season, great, that's one use. The other is when there's a problem, or in this particular case, what this was foliar fertilizer that had been applied, and the check strips with no fertilizer applied actually had higher NDVI values. What that would let you do is then walk there and examine things based on that yield map, in air quotes, mid-season. And at that point, there's things to look at. You can pull plants out of the ground in a very guided way, as opposed to trying to analyze that post-harvest, or when you're in the swather, which is usually when you see this, or potentially if you're in the sprayer, but you're going too fast and not keeping records at that point. So what I tell people that buy a multispectral drone is probably one of the best uses you can make of that drone is putting in a few check strips every time you do anything. If you're applying a fertilizer product, if you're applying a crop protection product, leave a strip or two, fly that several weeks later and see if there's a difference. The drones, when we fly them autonomously, so the mapping drones now, where we hit start, let them collect the data, just the mere process of stitching all that imagery together means it's done in 3D space. So you don't just end up with a map, you also end up with a 3D model of what that land looks like. This is just a quick way of capturing that data with a single photo. But if you map, then you get data products out of that. You can create digital elevation models, again, with fairly cost-effective drones. And based on that, you can create drainage plans. You can figure out where to put a culvert if you're with a county. I mean, there's a million uses you can make of digital elevation models. On our farm, we used it largely for variable rate. When I stopped doing it from the cab, where I was just manually turning it up and down, we would use elevation as one of our primary factors. Places that are collecting water or shedding water need very different levels of fertility. So we were doing a lot of that VR ourselves using elevation. The other use you can make of 3D, these 3D models, well, first of all, is just fall in love with your own farm. Looking at your own farm in 3D is miraculous, right? Even the binnyard is amazing to you. Nobody else cares, but to you, your binnyard looks amazing in 3D. In this case, you're looking at a silage pit and a barley pile. The 3D model is interesting, but what that does is you've now got the ability to measure volumes. You just trace the perimeter of whatever that pile is, and it'll give you the volume that day. Counties have started doing many of their aggregate pile volumes just by, again, using fairly cost-effective drones and existing staff rather than contracting out the service of measuring aggregate pile volumes. Counting cattle is almost becoming mundane now. Most of the feedlots are using some kind of counting system. So what you do is, if it's in confined feeding, you take a picture of an entire lot. Some will collect that with a mapping mission and then just pull the one photo out for each pen. And then there's automated software. This particular one that you see on the screen here is called countingthings.com. It was built originally, there was some around counting amoeba and that type of thing, but it was built largely for things like counting logs off your cell phone. Pointed at a pile of logs, it'll tell you how many there is. And it does a remarkably good job at counting cattle, as long as they're in a feedlot pen. If you're trying to do this on open range, it is more complex and there isn't a perfect solution yet. But I'm sure people I know John started to do some of this, and his students have tried to program for software development kits that will automate that on range. But it'll likely take thermal cameras and a lot more complex algorithms to do that. If you can count cattle, you can also count bales, similar software. I was trying to do a digital elevation model here and then just trained it on anything that has certain dimensions and looks round. That's a bale. It nailed it the first time. I did not find a single negative, false positive or false negative on a half section of bales. Really quick way to do that. Here's another shot thanks to John. I tend to reuse his material a fair bit because we've been putting out precision ranching workshops together. Correct me if I'm wrong here, John, but what you were looking at is using thermal as an estimate of heat tolerance. And what he had was two different breeds of cattle here, the Black Angus on the right with the higher temperature and the Speckled Park on the left with the lower temperature. He eventually migrated to other proxies for heat tolerance, like respiration rate and that type of thing, where again, he used a drone, positioned the drone over top of the cattle, and then monitored the respiration rate on those. The thermal drone, like I showed you earlier, really is ideal for finding cattle. This is a shot that I did last summer. New moon, zero light. Like I could not see the hand in front of my face because I was out in the dark. And a drone really can see everything because this is not light enhancement cameras. These are thermal cameras. So they're measuring the surface emission of heat. It's called a microbolometer as a sensor on there. So you can fly in complete darkness, feel quite safe doing that. You can see the trees in the shot. You'll know what your altitude is by just looking at the screen. And of course, there's all kinds of telemetry. So for finding cattle at night does work quite well. We used to have a bison herd, and my dad used to send me out there with the trike. We didn't even have quads back then. I'd have binoculars and try and figure out which heifer is calving, which isn't, which ones have produced any calves in the last few years, and take a few handwritten notes so that when we finally did TB testing, we would be able to cull a few. A drone works much better for this. So these bison in this shot had never seen a drone before, and bison of all the species I've ever flown around here care the least about drones. They really don't care when there's a drone flying over top of them. So great way to just create some records and look at which animal has a calf inside, which doesn't, collect the ear tag, and now you have some information you didn't have before. Staying with the bison theme, this is something we did last fall. There was a big herd out by Devon that got out. They were quite a ways from home, and there was already an accident with a vehicle, so they wanted to just find these two, or there were 6 missing. We ended up finding 2 of them that night. And this is just some screen capture from the controller. This is what it looks like when you're out in the middle of the night and you can put a floodlight on them. So this is a thermal camera used to locate them initially, then we put the floodlight on them, and this is from 200 feet up, so a 63-meter altitude. That's what bison look like. We found everything during that search. I mean, you could see fawns playing with each other. You could see a squirrel in a tree. It really is remarkable how well a thermal camera works, either at nighttime or in the winter. Midday in summer, it's not a great tool, but the rest of the year, which is much of what we need, a thermal camera really is amazing for cattlemen. This is another example. One of my staff was out trying to use a thermal camera to find a moose, and she captured this shot instead. Um, I just include this to keep it light, invading the coyote's privacy there. Um, this is this is actually very fresh footage. So I loaned out one of our thermal drones a few weekends ago. A neighbor here had a new pasture out by Wabamun, 2.5 kilometers by 2.5 kilometers, and there was 45 animals that didn't make it home in the first run out there to go get his cows back this fall. And so they loaned out the thermal camera, found them all that morning. The next morning, they found all the animals that had been missed the first time around, and he captured this shot in the process. So you can see the elevation here, again, almost 200 feet up. That cougar with her cubs was a couple hundred yards away from where his dad and brother were out looking for cattle and pushing bush, looking for their animals. So he was able to see there's no cows in that bush, but he saw with the thermal camera that there was another animal, zoomed in and just warned them not to go in there. Um, Interesting shot. Okay, if this was an in-person seminar instead of a webinar on the computer, this would be a little bit more fun, but we'll turn it into a guessing game anyway. Do you think herding sheep works well by drone? John was quoted as saying he had a big article. I think it was in the Western Producer, right, John, where the article was all about moving cattle by drone. And he says he kind of regrets that story a little bit because you do have to kind of choose whether you want to move cattle by drone or you want to monitor cattle by drone. You can't have them used to it and chase them with the same tool. But let's, I'll just play the video here. So YouTube is actually full of people using drones to move sheep. And often it'll be like two border collies moving them even when they don't have fences like this guy did. Um, and that works incredibly well until the sheep get used to the sound and then they don't care so much. So what do? There was guys in New Zealand and Australia that did this. They added sirens to the drones. This was early models when you couldn't just buy it from DJI. They had to design their own speaker and they would put either whistling sounds on there or barking sounds or some kind of a siren to get the sheep moving again until they get used to that new sound. And animals are like that, right? They just get acculturated to it and then they don't care anymore. So what do you do then? This guy came up with an even better solution. Take a look at this. So it's like oat bucket training. Every time he was putting his sheep into a new pasture, he'd let the drone hover there for 10 minutes, then open the gate. And lo and behold, in no time, they hear a drone, they're off and running. It's like the Pied Piper of Hamelin. They follow him right through the gate here and into that paddock. Okay, back to the guessing game. Do you think herding cattle works well? Let's take a look. Australian cattle, the accent. So with cattle, it really depends on a whole bunch of factors. You'll see a difference in gender. Steers tend to be more like this. Heifers will be a lot jumpier and start to circle much earlier, quite some distance. Cows will do one of those, either just not care or run, but there's also some that'll attack the drone. So it really depends on age, gender, personality of the animal, I guess. It does not work all that well. And John, I don't know if you want to say anything about what you've done with them, because you've done a fair bit of moving a cattle using drones. You're muted. Sorry, looks like your mic isn't working. I'll move on to the next one. I correct me if I'm wrong, but basically the summary from John was always, it's great for getting cows to push cows out of bush. You hover over them for a while, bug the heck out of them, so they pop out, and then they'll naturally rejoin the group. But it's hard to control their direction as individuals, perhaps for a whole group, though. John, I see you're unmuted now.
I finally got unmuted. So I did get quoted in I think not just the Western Producer, but also a U.S. magazine. I've used drones like a flying border collie, but I find that at first it wasn't good because once you started chasing them and they hear the motors, then they thought they should run. But what I found now with the incredible zoom, even on the lower model consumers, is so good. You just go high. And so if you're at 100 meters, they don't seem to care. And actually, I'm embarrassed to tell you that the heifer video that you watched where the cow was calving out, they were actually at 200 meters. I said 200 meters, that's 80 meters above what you're legally allowed to fly, right? You're only allowed to fly to 120 meters. So I said to my two interns, Pedro and Philippe from Brazil, why were you guys so high? He said, well, the heifer was giving birth. We wanted to make sure there was no way we could scare it. Well, at 200 meters, the M300, as you know, Marcus, it's not even a baseball size at that size, right? So I think what's really good is because I agree with you totally. Infrared is nice. You get half off a drone if you're a rancher in Alberta, if you include infrared in the purchase of your drone. But I find zoom for the cows is probably more useful. And I've said enough.
Yeah, no, exactly. Herding yaks. I'll just play this one real quick. I do have a buddy that has a herd down by Castor, Dave Weber. If you've never tried yak, Fleet Country Farms. I always do a little bit of advertising for them. And we've flew the drones there, and yeah, they move yaks. No problem at all. Also, don't fly in these conditions. I was only in the air for about 3.5 minutes, had a thick layer of ice on the leading edge. So that's the one situation where you can't fly even the newest drones. The matrices, you can fly them in pouring rain, but do not fly in icing conditions, please. I've had some customers lose their drones flying in these kind of conditions. And then one last one in the guessing game. Do you think herding bison works? And I'm actually the operator for this one. That's those 2 bison that we found out in the bush last summer. And we babysat them all night because we found them at 1 o'clock in the morning, stayed at fieldside just to make sure they weren't on the highway. And then I tried to move them, and you can see what kind of results I'm having here. They're just trying to figure out how to get around the drone. They're not moving away from it. And I figured out I'm not that great a pilot that day too. So not a great end to that drone. Just a couple more examples before we move on to other things. Noxious weed mapping is definitely something of high interest to not just to cattlemen, but to counties, weed inspectors, anyone that wants to get rid of the bad stuff like leafy spurge and spotted knapweed and all that type of stuff. This is a student that did that. He worked for County Lethbridge, and then in the summer worked for County Lethbridge. In the winter times, went to taking a GIS degree, and he figured out how to map leafy spurge. It's actually not an easy thing. We've tried to replicate some of the results. He did a great job. We didn't do so well, but artificial intelligence definitely will solve these problems fairly quickly. I always recommend to any farm customers, if you're going to have anyone else using your land, take some pictures or video or a 3D model, like in this case, before anyone else uses your land. I get calls a lot. We don't actually provide imagery service. I sell the drones. We train people how to use them. But I get calls all the time wanting me to really help the farm customer when they have a problem with the oil and gas company that they claim didn't restore the land to its previous drainage pattern. And it's hard to prove that afterward if you don't have it before. And with how many people own drones now, I always encourage people to take some pictures before you let anyone else use your land. And then if there is a problem, you've got some documentation. That's a video that I used to use back in 2015. I shot that one because at the time we really didn't think weed control was something we were going to do by drone. Oh my, how things have changed. Many of you that are on the call are probably here thinking I'd be spending the entire time talking about spraying drones, because that's what people think of when they think of drones on the farm now. big disclaimer right at the start. I'll get into regulations later, but there are no agricultural pesticides approved for a drone application in Canada yet. There are 5 products approved. None of them are agricultural. Actually, I heard there's another one. There's a 6th one, a copper sulfate product, but again, none for agriculture. Despite that, people are doing it anyway. So there are definitely people using it for plants and crop protection products, fertilizers, all of that. They're much larger drones though. So this particular one you're seeing there is a 40-liter machine. We now have 100-liter machines, and they keep getting bigger every single year. This is a legal use, so you can drop things from drones. Transport Canada doesn't care that we're spraying either. It's Health Canada that cares that we're spraying certain products. This is Steve Kenyon, Greener Pastures Ranching. He's got a career of regenerative agriculture and spreading legumes onto pastures using other spreaders. So he started doing it by drone. This is an Agris T10, the smallest spray drone that DJI has made in the last few years. And he's using it to apply largely clovers. But he's also doing some alfalfa and others, again, under some government funding that helps to defer some of these costs or defray some of the costs, and getting some good results in a wet year. It does take moisture to get seed to soil contact. Otherwise, a broadcast seed really doesn't work well, regardless of whether it's a drone or a ground spreader. This is an example of a trampling claim. AFSC had a program where you could measure the amount of crop trampled. There's elk herds of like 250 head, just the south end of the Peace River. They'll just follow the river and decimate the crops there every fall. But even if you have another wreck, like a fence broken, I've done some of those for people, resolve some conflict between neighbors where cows were out in the canola field all summer, and you can measure exactly how many acres are affected. This is a picture contributed by one of the people that attended our ag drone school up in the Peace. He happened to have his drone along when he had this blowout on his anhydrous tank. And the picture alone is interesting, but what it really brought home for me is how much a drone can add to a farm as a security device. I mean, things happen out in the countryside nowadays. Some of it is just evildoers, and some of it is just unfortunate like this. And you can access that type of stuff with a drone a lot safer than you can on foot. It's always a bad idea to confront anyone with a shotgun in your pickup. It's much better to just fly the drone out there, light them up with a spotlight, and do some security on your farm or for your community as part of a neighborhood watch. For a lot of counties, the first drone that I sell them is for this use, just checking beaver dams. Flying into something that rugged and remote is a lot simpler than trudging all the way through there, especially at times of the year when there's still ice on some of that. Definitely an easy way to save a few ankles. So that's the scouting drones, the mapping drones, and we're going to move on to application drones, the spraying side of things. So, sorry. Imagining all of you sitting at home and waking up with the babies out, but didn't wake anyone. So this is just a marketing video, but that drone, this particular one you're looking at is a 40-liter model. This year's model is 100 liters. And we're going up to 75 acres in an hour from a sprayer that costs $50,000. Drones are getting to the scale where even for large-scale crop production, they're starting to make sense. For guys that want to do pasture brush control and that type of thing, once it's allowed again, of course, the big disclaimer. A 40-liter drone is plenty big enough. You actually don't want a 100-liter drone likely for that type of a scenario because you need a big generator and you don't want to drag along that on a rough pasture. Drones are different from other ways of spraying. And the biggest way is just the way the droplets are created and dispersed. So with a ground sprayer, there's one critical piece of equipment. There's actually two. There's a pump. All the pump does is produce your desired pressure. After that, the nozzle takes care of everything, right? If you have 40 PSI, the standards on those nozzles, if it's a 110.03 nozzle, that means you're going to get 3 gallons a minute at 40 PSI. So the nozzle itself and the size of the hole is so standardized that it meters. It's actually doing a measurement of the volume of water per minute. It's also atomizing. And the principle there is high pressure, small hole, low pressure on the other side. So that laminar flow is broken into a whole bunch of droplets. Large, small, but hopefully a medium that you want. You choose the nozzle to get the atomization that you want. And lastly, the nozzle itself creates the pattern. You can see that in the image here. Flat fan nozzles, 110 degrees is what most people are using most of the time, produces that beautiful pattern with droplets that are metered at a known rate. All done by one little piece of plastic or metal or ceramic or whatever that particular nozzle is made of. With a drone, all three of those functions are done by a different part of the system. So drones look something like this. There is metering that's done by pumps and flow meter. So hanging right underneath that tank, there's two pumps in this particular model. That was an Agris T50. Two pumps mounted above it as a flow meter, and depending on a user input value of swath width times the current speed, it puts out the rate of volume of water. We've tested these over and over, and it's within 1% every time. But that's all they do. They deliver the water at a known rate. They don't atomize. The atomization is done by an atomizer. There were earlier models that had flat fan nozzles, but those are kind of gone the way of the dodo bird already. All the companies are now building these atomizers. It's an electric motor spinning a little spinning disc. Think of a granular spreader. That's essentially what it's like. The atomizer is shaped a little differently, but low pressure water is dropped into the center of that atomizer, spins around, and that spins off the droplets. You get a more even droplet profile that way. And you can change droplet size on the go. With the newest model, with the T100, we can go from a 10 micron average droplet size, a mist, truly a mist, all the way up to 500 microns, which is very drift resistant. And you can just do that by moving a little slider on the screen because it changes the speed of that motor. Thirdly, the dispersal is done by the propellers. It's actually not done by that. There is a pattern that comes out from the atomizer. It's like a little bowl shape, but that all gets blown apart by that mini tornado underneath the drone. The propellers are used both for flight and for distributing the droplets. So you actually have three different systems in these drones doing the metering, atomization, and pattern dispersal, which in the long term will help us to improve the deposition further and adjust to changing circumstances, because wind is a real issue that we need to worry about with drone application. We're typically flying 10 to now probably 14, 15 feet above the canopy with the larger models. And that gives wind an opportunity to interact with small droplets. So we need to be careful about droplet size and about how we distribute them. What that atomization system looks like is something like, it's the pumps. I get the wrong part of the video here. There's the atomizer. Just a blow apart view of what that looks like. So you've got water coming off these fins and atomizing right at that edge. Quite a neat system. What the pattern dispersal looks like is something like this. So this is at our yard. You can see the amount of vortexing, that mini tornado or virtual boom effect. Notice also what it does to the plants. So for things like fungicide and desiccant or anything in crop where you've got a tall crop canopy that you need to penetrate, or orchards, that downdraft has that added function of also moving the plant. In addition to giving a very turbulent deposition, research trials, even from skeptics, often is very surprising. They'll compare 15 gallon an acre of fungicide, of water for fungicide, to 3 gallon an acre of water when using the drone out of necessity. And the coverage looks horrible in comparison from drone, to be fair. It's not very even deposition. That's something we definitely need to work on for drone application. It's not as good as ground sprayer, but it's good enough for that application. And in the end, the results are often very similar with no statistically significant difference either in the efficacy of that product or in the final yield. We're not going to spend a whole bunch of time here on spreaders. This is how we calibrate them. We found better tools though, because many of the tools with all that downdraft just don't stay in place. Those are some tubs that we tried. This, if you are into spreading by drone, this is the best device we found. So it's manufactured by Amazon, a German manufacturer, for ground spreaders. but it works really nicely for capturing all the little granules. And they have an app that you can scan every individual mat like this, and it'll tell you the coverage percent. I'll skip the fun videos here, because otherwise we'll run out of time. So just a couple of notes now on how all these drones work together. When you're spraying, you need an accurate boundary. And that's especially the case on pasture. Drones for the ranch is a topic for today. Most of the crashes that we've seen over the last few seasons have been propellers touching shrubs. Not full-size trees, typically, shrubs. And because of that, you need a really accurate boundary when you're spraying for brush control on pasture, that type of thing. These are all the different ways you can create those. And as nice as it would be to walk around the perimeter or to use the controller, that's number 3, or to fly the drone manually first to create a boundary, all those really aren't that practical given our scale. The mapping drone becomes the way of doing that. So we fly one of the Mavic 3 multispectrals first to create the map, to create the boundary or prescription for the spraying drones. And the process there is, it's called an orthomosaic. And I've just got this visual to kind of show what an orthomosaic is. It's just a series of pictures collected by the drone, then a big black box that georectifies the images, color grades them to create an accurate map. And with RTK level accuracy, you can get that final product to be within 2 to 3 centimeters, like inch accuracy, if that's what you need. If you need it quick, you can also get 10 centimeter accuracy and get it in NASTA time. And then that's used to create the boundary. If you do want to do prescriptions, there's also NDVI and similar things that you can do with these drones. So NDVI stands for Normalized Difference Vegetation Index. It's basically using those near infrared bands that you see here on the right side as a way to differentiate healthy and unhealthy vegetation and use that to then create a prescription. And that principle of using near infrared light really helps, especially with things like VR fungicide or even spot spraying of weeds, differentiating different types of plants from each other. Types of prescriptions that we've created, I mean, most of what we create here at Landview is either for research or for just experimenting or for our own farm. So we're not applying by drone because we're not allowed to at this point, but we're applying by ground sprayer. So the farm I grew up on, they have individual nozzle control. So we were doing VR fungicide prescriptions at 50 centimeter off, and we'd dumb it down to 1 meter grid. So basically 2 nozzles would turn on and off along the length of the boom at a time, depending on whether there's crop there or how healthy that crop is, and only spend money on the good parts of the crop and not spend more money on the bare parts of the field. You can also do some of this blanket base rate and then VR higher and lower, depending, of course, on the label requirements for that product. What the process looks like for creating a prescription like that, just done a very quick way of doing that. You start with that orthomosaic map here, then you color, you assign these formulas to create the vegetation indexes. Then you zone it. So you're grouping, essentially, the software is grouping like components with each other to create zones. And this is something a farmer can do themselves, right? We do courses where we teach people how to do this in our drone spraying clinic and how to create these kind of prescriptions. This isn't something that needs to be contracted out. Definitely something a farmer can do themselves. And I argue can do it better than anybody else could because they understand the factors on that field. It's important to know what's happened there over the last few seasons in order to understand the crest map. So this is essentially the finished product. You create those zones and then create a grid. You plug that into your controller, and now the operator can be applying at different rates across the field as they spray. We've tried to do some of this for brush control, for weed control on pasture too. So we had a research authorization through Corteva for 3 years where we could spray Lontrell XC by drone. And the first step that we did was just create polygons, used machine learning here. The platform was Picterra, but there's machine learning, as you all know, is so prevalent. There's other platforms now that can create those polygons for you. Then we would test the product in different rates of water. So this was 3-gallon maker, 5-gallon maker, and 10-gallon maker, just to test the efficacy, because that's the primary research currently being done on drone application of pesticide is what water rates will be sufficient and whether the efficacy is equivalent to ground application or aerial application. We always test the spray quality at the same time. So this is just some samples of what water sensitive paper looks like, with D being drone sprayer and G being ground sprayer. You can tell the difference if you do this all the time. The droplets tend to have more little tails on them because droplets from a drone don't fall by gravity. They get twisted around and there's a lot of microturbulence. So you'll get longer looking droplets often. But what you're doing here is reading the paper to see how good the coverage is, how many droplets you've got per square centimeter. If you have a device for quantifying all of this, you're looking at droplet sizes to make sure that they're drift resistant enough and have the efficacy that you're looking for. So I really encourage people, if they are going to get into drone spraying, to start using this water sensor paper routinely. And then the final product that we created in that project was really the ability to just spray parts of the field. This was a pasture that we mapped for thistle. All the orange dots are thistle plants that were definitively identified at a 70% accuracy level. That's the best we could get. Only 70% on whether an individual dot is or is not thistle. But it was still good enough once you go to this density map to hit the densest part of that pasture with some Lontrell in this case, and not spray the parts that don't have dense thistle. On the right is a picture of what the results look like. I mean, this was probably later than we should have been spraying. Ideal timing would have been a little earlier, but we toasted those thistles. I mean, this is a walk through the part of the polygon where we didn't spray. You could see a few escapes there, and that's just part of doing this, is you have to be able to accept some escapes. But that area that had the thickest thistle did a great job. Leaves us with about 13 minutes to do the boring part last, but also the most important. So rules. Just going to cover a few of the rules here, both from an aviation perspective and a pesticide perspective. It is fairly simple to get certified to fly a drone. I hear farmers all the time say, I don't want to buy a big drone because I don't want to get the certification. For a basic certificate, it's an investment of about 4 hours of your time, 3 hours of learning, 1 hour writing a test, and $10. It costs $10 to write that exam and $5 to register your drone. Sorry, that's gone up to 10, so $20. The advanced certificate is a lot more challenging. So if you want to get into spraying drones, you do have to pass that advanced certificate. Because of the weight of the drone, the risk is higher. You need to understand airspace. So about 25 hours of your time and $600 or so is what you should budget if you want that advanced certificate. It's not an overly difficult process. Anyone can do it if they just put the time in. There was a lot of change this year in terms of the drone regulations. Transport Canada rolled out changes to a whole whack of things. This is the list. So there's the ability to fly extended visual line of sight, which means if there's a visual observer present, you can now fly within 2 nautical miles of the drone, of the operators, without actually having physical visual line of sight constantly, if the pilot has an advanced certificate and the visual observer has at least a basic certificate. Then there's the lower risk beyond visual line of sight. We won't get into that. It's a whole new certification scheme. That is probably more for delivery drones or pipeline inspections, that type of thing, not for ranch use. Same with sheltered operations. That's for urban operations, largely flying between buildings. There shouldn't be manned aircraft, so they reduced the requirements there. But the one that's most important is medium RPAS. They created a new category for drones that are 25 kilogram to 150 kilogram. Previously, you would have needed an SFOC, a Special Flight Operations Certificate, and that's no longer needed. The advanced certificate is going to be good enough for up to 150 kilograms. Of course, the newest drone is already 177 kilograms if you load it fully. It was great when they started creating these new regulations 2 or 3 years ago. Everything's always changing and evolving, but transport really has done well to incorporate drones into the airspace. I wish I could say the same. I hope there isn't too many regulators on the line, but our regulators for pesticides have not done as well to keep up. And there's a lot of farm customers that are waiting for pesticide labels to become available. Currently, no herbicides, fungicides, or insecticides are approved for agricultural use. There's these 5 products, and I heard there's recently another one But there's 4 of them that are for black fly and mosquito use. And Gardelon XRT is a herbicide, but it's only approved for industrial use, not for agricultural. What you can apply, though, is things like fertilizers, both granular and foliar. You can do seeding of cover crops. You can apply some growth promotants like Utrisha N, that type of thing, biologicals, but no pest control products. So with all those rules out of the way, here's where I see spray drones fitting, both on the ranch and on cropland. They're largely for accessing hard to access areas, places you can't get to on the ground through, really deep canola. Nobody's going to walk into that crop to scout it. You can now, and you can spray. The lowest capital cost really is a big driver for people buying drones right now, because they can't afford a high clearance sprayer, and this is an affordable high clearance sprayer. The lack of trampling is also another reason people want to use it for desiccating, because it won't trample 3% of the yield. And then the other big one is the what if scenarios. And I've got a whole long list of them here. I won't spend much time on this, but I have people that are using it for reseeding unseeded acres, right? Those wet spots you can't get a seeder into, you can certainly overfly it the next day with a drone, put in a slightly higher rate because you're broadcast seeding and not incorporating, but it's waterlogged soil, and those seeds, depending on the crop, will germinate. So lots of uses, and just so you have a sense of pricing, this is what a full package costs for a sprayer that'll do. This one would be 35 acres in an hour. It's called a T50. If you're interested, price is dropping next week because that is going to be last year's drone soon. And for imaging drones, you're looking in that $7,000 to $10,000 range. And some of those are subsidized by government programs as well. We're almost at the end of our time here, so quick sales pitch on what we do. We do training. We have 3 different types of training: an ag drone school, which is just about safe operation of drones, the basics of how to fly. Most of the people that come have never flown a drone or only for fun once. We teach them how to do all of that, how to do some basic mapping, all the different uses on the farm and what some of the different cameras are about. And then the drone spraying clinic, we've shortened that to 1 day now to make it easier for people to attend by having some of the classroom portions available online instead. But we teach you the ins and outs of safely applying product by drone. And yes, some users may use pesticide. We don't teach you how to use pesticide, but we'll be doing that as well once we have labels that are approved for agriculture. We do these schools all over Western Canada. I don't have the spring schedule ready yet. One other quick pitch. Many of us have gotten together now to create a Canadian Agricultural Drone Association. We're going to be doing a membership drive coming up, and the first big thing we're going to do is an Ag Drone Summit, April 7 to 9. Some of the people you see on the screen, there'll be speakers there as well. It's going to come do a talk there. John is actually putting on a full 1-day precision ranching workshop for those that are into cattle. On April 9, I believe is the date for that. So look up Ag Drone Summit online, and that's in Camrose for those that are from Alberta here. So I came in right on time. We got 5 minutes left for Q&A. I see there's a bunch of chats here. Is someone going to read those to me, or should I be reading?
I will read them to you, Marcus. I don't know if Ed or John want to chime in. They're more than welcome to as well. Riolito has a question. I'm thinking of applying for a grant focused on bees, wondering what other applications of drone technology can aid beekeeping.
I actually have some customers that bought it for leafcutter bees, for distribution of the shelters and figuring out where to put them. One of them wanted to evaluate how active the bees had been based on the plants on the alfalfa itself. For other beekeepers, I'm not sure. I haven't thought of too many, frankly, and don't have honeybee keepers as customers at this point. I'd be interested in hearing your ideas, though. Reach out to me.
Okay. And then he also wanted to know what's the coldest temperatures a thermal drone can still fly. He's just curious.
So to be legal, you need to meet the manufacturer's specifications for that drone. Most drones are rated to -10. Consumer drones typically are to 0 degrees. Most drones are -10, and some of the high-end drones, like a Matrice 30, would be to -20. The thermal camera will work below that as well, but you need to acclimatize the glass on that camera to the outdoor temperature before you use it.
Great. What if I need the drone to be customized? Who do I go to?
Depends on what kind of customization you need. I mean, there aren't too many Canadian manufacturers of drones. There are customization kits, essentially gimbals that you can buy for mounting drones. And there's one particular drone that most people can find a way to customize to make it work for their payload, the Matrice series. So Matrice 200, 210, 300, 350, and 400. We're on the 5th generation of that drone now. The newest generation could carry 7 different cameras at a time, has 7 ports for them. There's a payload SDK where you can then write code if you wanted for that particular payload as well. Short of that, I mean, I know some people that are building drones as well if you needed some extreme customization.
Thanks, Markus. Just a reminder, folks, if you have questions, to pop them in the Q&A or into the chat. Vinye wants to know, do you find Pix4D better than DJI Terra to do NDVIA and other vegetation health indices analysis?
Yes. I'm a DJI vendor, so I mean, I do like the DJI product as far as the drone itself goes. But when I use my DJI drones, 90% of my stitching is done in Pix4D. I do like DJI Terra for 3D modeling, but for NDVI and multispectral analysis, Pix4D fields in particular just cannot be beat, both in terms of data collection speed, processing speed, and the analytics that are built into it.
Awesome. Josie wants to thank you for acknowledging RDAR's funding. And then I wanted to know if Ed or John wanted to chime in at all around what they're seeing for the limitations, and maybe the sky is the limit in terms of drone application for producers. So Ed, do you want to go first?
Actually, I'm just going to throw a question back to Markus. So Markus, I'm kind of curious about the NDVI I can see as being a really important commercial application for being able to assess in real time your pasture biomass and or quality. My question is, at the high spatial resolution that these drones can now collect data at, are there good software interfaces to be able to process that data effectively, or do we have a lot more work to do to be able to integrate? With anytime we talk about precision agriculture, we're usually generating a lot more data than we can effectively process. So my question is, are we at that point where we're generating way more data than we can effectively handle in terms of producing usable products at the ranch level, or are we catching up in that regard?
We're catching up in that regard. One of the holy grails, of course, is speciating vegetation, like figuring out whether that's a Canada thistle or a South thistle. Doing that requires incredible resolution, and with incredible resolution comes incredible data load. That's not possible in real time or close to real time edge computing. But for 2D orthomosaic and NDVI for processing those prescriptions that I talked about earlier, for example, we were flying half sections in a single battery, 20 minutes. We were processing that in another 15 minutes, and start to finish, we're 35 minutes in to create a variable rate prescription for fungicide. And that's with using multispectral data. So once you build a pipeline for a specific thing, you can always find a way to minimize how much data you collect. Like, we collect the data at 20% overlap. For those of you that have done mapping before, that's unheard of, and people always challenge me on it, but I'm happy to show ways of doing that quickly in Pix4D fields. Someone asked about that earlier. There are ways of making that work. For your specific example, though, Ed, where I thought you were going with this with the forage biomass, what's often has been missing for forage biomass is the height of that plant. Mm-hmm. We're seeing reflection of a plant, and when those are grasses, you're seeing reflection from an average reflection from the grass, and it could be this tall, or it could be this tall, or it could be 2 feet tall, and that's a very different level of biomass. So that type of data and using that for forage biomass is something that I think a lot of us would like to do. I know you're doing some work on that. And John, I think others at TRU are as well. Locke was there. So yeah, those will take a lot of data.
Yeah, and that's
LiDAR may do that.
Absolutely, and that's some of the work that we're doing, where we're trying to look at the integration of the LiDAR and the multi-spec, which in a research context, that's maybe okay, because when we're talking about flying multiple drones, multiple sensors, and much more expensive drones and much more expensive cameras, in the case of the LiDAR, do you foresee a point where maybe the LiDAR platform or the LiDAR camera will come down in price to the point where for an individual rancher, they might be able to afford it? Like
the Mini 5 Pro was released recently, and it had LiDAR sensors that measure distance to obstacles. That's quite a difference mapping at that level of resolution compared to what you'd need to sense plants. But if you were doing a point inspection and just lowering the drone down to some height where you could measure the height of those plants in a few points and then use that to create a heat map, I can see that as entirely doable with very low-end equipment very soon. A $1,500 drone has LiDAR on it for a different purpose, different type of LiDAR. Don't get me wrong. It's not collecting that data. It's just using it for sensing. But the technology is very affordable in the end if we just build a way to use it.
Yeah, building the way to use it is the key. And that's where, as I said, we're often generating a lot more data, but if we can harness all that data and make up usable platforms for producers, I think this will take us to great places.
That's what you're for. That's why you guys are piloting all this for us.
Yeah. The other thing, can you hear me, Adrian?
Yep.
The other thing that I'm very excited about, and we'll showcase this in April at the drone workshop. I'm so fortunate to be able to work with Dr. Bork, and he brought in at first the virtual fencing collars, No Fence from Norway, and also we're now working with a second collar manufacturer, virtual fencing collar E Shepherd from Gallagher. But what Ed and I were able to figure out is that we're getting a GPS signal off those collars, and it's super accurate. And what I'm super stoked about is flying the drones to the collar autonomously. So with Ed and his master student Alexandra's help, we first took the controller and we typed in the GPS location of the cow we wanted to see. And it didn't matter if the cow was 800 meters away or 8 kilometers away. And we'd hit a button and off the drone would go and it would execute it. Well, now I have drones inside of a box called the Dock 2, and I have the eShepherd software open. And my students can quickly just look on their screen, see the map of the ranch, tap the cow that they want to see out on the range, and it brings up the GPS coordinate. They copy it with the mouse and quickly paste it into the Dock 2 software and push a button that says execute. And like magic, the box opens up. The box sits out there on the ranch, and it takes off and it flies to the ranch. Now, to be legal, we send a text to the ranch owner, and he's supposed to be watching. I'm not sure he's always there watching, but that we're doing it anyways. We're sending him a text message. We're going to fly the drone. Certainly works really good in British Columbia. We don't have to worry about planes. I would love to do that with Ed at the Kinsella Ranch, but this fall we ran into a huge problem with crop dusters. I was out with one of Ed's undergraduate students, and she was my spotter. We had 4 or 5 planes coming into the Kinsella Ranch, and I was like, well, we don't have any crops. What's going on? Well, they're crop dusting neighboring fields, and then they're doing using Kinsella, Ed's ranch, to make a turn. And the scary thing for me, we were out there trying to map the ranch, and they were flying at 100 meters, the same height that we were at. So fortunately, there were 2 of us. She could keep an eye on the plane, and I was on the sticks. And if I thought we were even close to having a problem, I could kill the motors on the drone, and it would immediately drop down out of the sky. But fortunately, we didn't have to do that. But I see that as some of the real positives moving forward. but also I think we're going to have to come up with something, you know, to because I think it's these small aircraft like these crop dusters, and a lot of them don't even have their, what do you call it, their transponders on. Like some planes I see, they show up on my controller. A few of the crop duster guys did, others didn't. So it was really kind of bizarre.
Perfect. Thanks, Ed, and thanks, John. And Marcus, I see you've answered Cindy's question about looking for a drone that can do both the LiDAR and the thermal. So there is one that can do that for anyone else who is wondering. And I want to thank all three of you for spending your evening with us. Such a great presentation, and the sky, to be cliche, the sky truly is the limit for where we're going to get to in terms of how drones are applicable both on farms and ranches. So something to look forward to, and hopefully we can get you guys together again, maybe for some in-person demonstrations or another webinar again with more great footage. So thank you to Marcus, Ed, and John. Thank you so much. And thank you to our audience who came, and we did record it. So we'll post it and send out an email with the link. So thanks and have a great night, everyone.
Thank you very much, everyone.
Bye.